Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P2563 indicates an issue with the Turbocharger Wastegate control actuator position sensor output voltage being outside the acceptable range. This component plays a crucial role in managing the amount of exhaust gases that bypass the turbocharger, thereby influencing the vehicle's performance and efficiency. The wastegate control actuator position sensor is typically integrated with the turbocharger, and its primary task is to relay the position of the wastegate to the powertrain control module, PCM. In essence, if this sensor detects that the voltage readings are abnormal, either too low or too high, then it alerts the PCM to trigger this specific DTC. Troubleshooting this code involves a series of inspections targeting the turbocharger, sensor, and related electronic circuits. Understanding of both the physical and electronic systems is essential for an efficient diagnosis and repair of this issue. The turbocharger wastegate control actuator position sensor is an integral component of the turbocharger system, responsible for ensuring the correct flow of exhaust gases. Located within or near the turbocharger, this sensor monitors the wastegate's position and transmits voltage signals to the PCM, which assesses the engine's performance. An output voltage that is either below 0.31 volts or above 4.78 volts indicates a fault, prompting the PCM to store the DTC P2563. Understanding the position sensor's location and its operational role is crucial, as any malfunction affects overall engine efficiency. It not only influences turbocharger functionality, but may also lead to decreased fuel economy and increased emissions if left unresolved. Identifying the abnormal voltage readings is the first crucial step in troubleshooting this DTC. Several potential causes can result in the triggering of DTC P2563. A faulty turbocharger may be the root issue. If the turbocharger itself malfunctions, it can cause irregular wastegate behavior, which subsequently affects the position sensor's output. Wiring issues in the external circuit could also lead to erratic voltage readings. This could be due to damaged wires, poor connections, or bad grounds that impact the integrity of the signal. Finally, a failure of the PCM itself can also contribute to the problem, especially if it misinterprets the sensor readings or does not provide the proper voltage output. Each of these factors needs thorough inspection to determine the exact root cause of the DTC. Various symptoms indicate that DTC P2563 has been triggered and may affect engine performance. The most noticeable sign is the illumination of the check engine light on the dashboard, alerting the driver to potential issues with the vehicle's engine management system. Additionally, the vehicle may exhibit reduced engine performance as the turbocharger's efficiency is compromised, leading to sluggish acceleration and less power during driving. Moreover, increased emissions may occur if the sensor's failure impacts the air-fuel ratio adversely, which could lead to a failed emissions test. Understanding these symptoms not only aids in diagnosis, but also informs the driver of underlying mechanical issues that require urgent attention to prevent further damage. The first step in troubleshooting DTC P2563 involves turning the vehicle ignition to the on mode without starting the engine. After this, connect the Honda Diagnostic System, HDS, and monitor the EWG voltage from lift sensor. This value must fall within the specified range. If it is found to be less than 0.31 volts or greater than 4.78 volts, it indicates that a failure has been duplicated. This step is crucial as it confirms whether the sensor is functioning correctly within the specified parameters. If the values are out of range, This directly points to an abnormality in either the sensor itself or the components linked to it, requiring more focused inspection. The second troubleshooting step requires disconnecting the turbocharger connector, specifically the 5P connector. After all connections have been safely removed, use jumper wires to connect terminals number 3 and number 4 of the turbocharger connector. Following this, turn the vehicle to the on position again and check the HDS for the EWG voltage from lift sensor value. Under normal conditions, this value should read less than 4.78 volts. If the result is as expected, it implies that the turbocharger operates properly, but points to either the sensor or its circuitry as the issue. Should the value exceed the limit, it further narrows down the diagnosis to the turbocharger apparatus or its related components. In this step, both the turbocharger connector and the PCM connector, specifically connector E, the 80P connector, need to be disconnected carefully. This step establishes a clean slate to diagnose the circuit conditions without interference from active components. Using a multimeter, various inspections should be performed on the VCC2, DCWGL, and SG2 circuits to assess the wiring integrity. Each circuit should show resistance of less than 1 ohm under normal conditions. This indicates a properly functioning circuit without interruptions. Additionally, checking for shorts to ground will reveal whether any wires are compromised. If any abnormalities are detected during these checks, it confirms an issue with the relevant circuit needing immediate attention. The final troubleshooting step involves inspecting the PCM itself if all previous checks yield normal results. If the turbocharger and the various circuit conditions are deemed operational, the PCM is suspected to be at fault. In this case, further testing of the PCM's capabilities should be carried out to confirm a failure. A malfunctioning PCM may misinterpret sensor signals or incorrectly output voltages, leading to DTC storage without actual faults in the related components. Diagnosing the PCM as the underlying issue can be challenging, but is vital for ensuring the vehicle can perform optimally and reliably. If confirmed, the PCM must be replaced or repaired to resolve the DTC. Once the suspected faulty components have been addressed, it is essential to clear the DTCs from the PCM memory to complete the repair process. After clearing the codes, a test drive should be conducted to determine if the issue has been resolved effectively. During the test drive, monitor the vehicle's performance, paying attention to any unusual behavior along with the HDS readings. Finally, after a successful test drive and continuous monitoring showing normal operation without the reappearance of DTC P2563, the repair can be considered validated. This verification step is paramount for ensuring that all repairs made are effective and that the vehicle is returned to optimal running condition. Preventive maintenance can significantly reduce the likelihood of encountering DTC P2563 in the future. Regular inspections of the turbocharger and its components will allow early detection of wear or damage that could lead to circuit failures. It's also essential to monitor the electrical connections regularly, ensuring that there are no exposed wires, corroded terminals, or loose connections that might interfere with the signal flow. Scheduled diagnostic checks on the vehicle's engine management system can help catch potential issues before they escalate into serious problems. Addressing these preventive measures will not only help maintain the turbocharger's integrity, but also promote better overall vehicle health, leading to improved performance and efficiency. In summary, addressing DTC P2563 requires a systematic approach to diagnosing and rectifying issues related to the turbocharger wastegate control actuator position sensor. It's vital to confirm the sensor's output voltages and inspect related circuits thoroughly for faults. If abnormalities are detected, swift action is necessary to prevent ongoing issues that can affect vehicle performance. Furthermore, implementing regular preventive measures and inspections is crucial for long-term reliability. By remaining vigilant and proactive, vehicle owners can maintain their Honda CR-V's performance and efficiency, steering clear of costly repairs down the line. Ultimately, understanding the role of each component will facilitate better informed decisions and smoother vehicle operation. Please like and subscribe to the channel. See you next time.